This call is now being recorded.
Good morning. Welcome you all for the today's class. Yesterday, Madam discussed about the need for the velocity analysis. Hope you got the clear picture about the concept of relative velocity method. Today, we'll be solving one problem pertaining to the discussions what we had yesterday. First, we should know the need for velocity analysis. First objective for the velocity analysis is to find out the velocities, either linear velocity or angular velocity. So both velocities are possible to find out using this velocity analysis method of unknown links or points. So we are having many links or many joints, many points we are having in a link. So those velocities, linear velocities and angular velocities can be obtained with the help of this velocity analysis approach. So the relative velocity analysis, relative velocity method can also be called as velocity polygon approach. So we are going to proceed with drawing velocity polygon to find out the velocities of all the points. So what is the need for finding out the velocity? Finally, we are going to arrive at the acceleration. So we need, in order to find out the dynamic forces acting in a mechanism or any mechanical system, we need to find out the dynamic changes in the acceleration. So as a result, we need to find out velocity. So if you find out the velocity, the rate of change of velocity will lead to acceleration. So what are the inputs which are required for the velocity analysis? How to proceed with velocity analysis problem? So we need to start with the dimensions of all the links. So whatever may be the mechanism which is given, so dimensions of all the links should be given. So with that we need to proceed. Otherwise it is not possible to proceed because it is synthesis is a prerequisite for the analysis. So synthesis பண்ணிட்டு we arrive at certain dimensions of all the links. Like here, if you look at this is your four-bar mechanism. It is crank. It is your coupler. It is your rocker. And this particular thing is called frame. So these are all the four links which are used in a four-bar mechanism. So இதோட dimensions எல்லாம் என்னப்பா கொடுத்திருக்காங்க? What are the dimensions which are given for crank? What is the dimension of the crank? Can you only talk? What is it?
Screen share.
Screen share. Okay. சொல்லலாம்ப்பா. Is it visible now?
Yes, sir.
Yes, sir.
Okay. Sorry for the interruption. So as the first step, we need to know all the dimensions of the links. Here the crank dimension is 60 mm, correct? And coupler is 400 mm, rocker is 180 mm, and the frame dimension is 360 mm. So in the dimensions changes now, we need to proceed further velocity analysis. So first and foremost requirement is to understand or to know the dimensions of all the links. So these are all called as dependent variables, because if the orientation is changes, the entire if the crank angle is changes from 90 degree to another degree, the orientation of all the links are going to change. So these are all dependent variables. So next thing is we need to know the configuration, that is outcome of the position analysis, or we need to know the crank angle. Okay, so crank angle we are not supposed to know. That is here. What is the crank angle given here, pa? What is the crank angle given?
90 degrees, sir.
Yes, it is. The crank with respect to the frame, it is making 90 degrees. So crank angle is 90 degrees. So input crank angle should be known. It is an independent variable. So we can vary this crank angle according to our convenience. So for this particular instance, we are going to analyze the velocities. So for 90-degree angle of crank with respect to the frame, what are the velocities of other links that we are going to analyze? So dimension should be known. The crank angle, that is crank input angle, is supposed to be known. Next, third thing is velocity of the driving link, which is a driving link here. It is crank. So crank oda velocity should be known. At what speed it is going to rotate. Either speed that is 200 rpm or 300 rpm, something should be given, or in terms of some 20 revolutions per second. 20 revolutions per second. So any data related to velocity of the driving link should be given. So with this only we need to proceed to find out the velocities and angular velocity, linear velocities and angular velocities of all other link. So what is the final outcome of this velocity analysis? We are able to find out the angular velocity of all the links. So if we know these input data, that is dimensions of all the links, input crank angle and crank velocity, all the velocities at all the points can be obtained by doing velocity analysis. So if I want to find out velocity at this particular point, I can able to find out the velocity. Or if I want to find out the velocity at this particular point, I can able to find out. So in the location velocity polygon approach use பண்ணி I'm able to find out either angular velocities or linear velocities. Both are possible. So before proceeding to the problems, any doubts about the need for velocity analysis? Any doubts?
No, sir.
Okay, so we proceed. So before solving the problems related to velocity analysis, we should know some fundamentals. Yesterday, madam taught about the basic ideas of relative velocity concept. That's what we are going to discuss throughout the topic. Suppose if you are having a link like this, take this as case 1, this is case 2. Okay, you consider the link OA, okay, which is rotating at 100 rpm in anti-clockwise direction. It is clear. So how to find out the velocity at point A? How to find out the velocity at point A? This is a link which consists of 150 mm, for example, I'm saying it is 150 mm length, and which is rotating at 100 rpm and counterclockwise direction. O is the fixed point and A is the moving point. Okay, so how to find out the velocity at point A?
R omega, sir.
R into R omega. Yes. So velocity at point A, okay, velocity at point A with respect to O. Okay, so we can denote like this. Velocity of A should be written on the right hand side, and with respect to the point can be written on the left hand side. That is equivalent to R into omega. What omega? Omega of the particular link. So what is R here? What is R?
100.
Sir, 100, no,
100, 150 pa. R is nothing but the length. Okay, the length OA, and omega is your angular velocity of the link. Okay, how to find out the angular velocity of the link? Only speed is given. How to find out the angular velocity of the link? Can use this formula 2 pi n by 60. Okay, to find out the angular velocity of the link, you can use the formula 2 pi n by 60. So n is given. Okay, so n is given, that is 100 rpm. Okay, with this we can find out OA is nothing but 150 mm, and with this we can find out some value, so that you will be obtaining some value for velocity of A, okay, with respect to O. Okay, what is the unit for this one, pa? What is the unit for this one? What is the unit for OA?
Radian per second, sir.
No. What is the unit for OA?
MM, sir.
MM, sir.
sir.
Yes. Unit for OA is mm. What is the unit for omega, angular velocity? Radians per second. Okay, whenever you are multiplying the radians by second with the another magnitude or another unit, so yeah, radians will be silent. So the final unit will be mm per second. Okay, mm per second or meter per second, anything you can take. So the basic unit for velocity of point A, linear velocity of point A with respect to a pivot point is called some value into mm per second. Is it clear? Okay, so we can call this as absolute velocity. Why?
Sir,
Can
because
call this
one
as,
fixed point.
yes, we are measuring the velocity of a particular point A that is rotating with reference to a fixed point. So this is your fixed point. So whenever you are measuring the velocity or determining the velocity of a moving point with reference to a fixed point, then it is said to be a absolute velocity. Is it clear?
Yes.
Okay. Then in this case, you can write like this. Well, instead of velocity of A with respect to O, or simply we can denote it as velocity of A. All are indicating that it is linear velocity with respect to absolute point. So in the absolute point with respect to O, it is need not required. Simply we can write VA, it is nothing but velocity of point A, which indicates the absolute velocity. Okay. Now, the same case, you are attaching another link with point A, and this is the link 2. Okay, so red color is the link 1 and the blue color is link 2. Okay, if you are finding out the velocity of point B with respect to A, then it is said to be what? If you are finding velocity of point B with respect to A, what is the name for this? Or if you are finding velocity of B with respect to point O, you can either obtain velocity of B with respect to A or velocity of B with respect to O. Both are possible. So what is the name for each thing? What is the name for first case and what is the name for second case? Please respond. Velocity of B with respect to A. Pa.
Sir, velocity of B.
Relative velocity.
Yes, its name is
Relative.
relative velocity. Why
Velocity. Sir,
relative
because it's
velocity?
moving. But the link is fixed.
Yes, velocity of B we are finding out, but with respect to A is also moving. Okay, it is also moving link. So whenever you are finding a point's velocity with respect to a moving point, then it is said to be what? Relative velocity. Okay, but velocity of B with respect to O, what is that?
Absolute velocity.
Absolute velocity, because you are finding out the velocity of point B, okay, with respect to a fixed point, that is O. So both are possible. Let me brief how to find out the both possibilities. Then you are able to appreciate the need for velocity analysis. But time being, you should know what is meant by relative velocity, what is meant by absolute velocity, what are all the formulas that we are going to use. So whenever you are finding out the velocity, linear velocity for a particular point, you should use R into omega of the length. R is the dimension, that is length. Okay, and where omega is angular velocity. This formula you are supposed to keep in mind. And before that, we know how to find out the magnitude of the velocity, that is point A, and how to find out the direction. We know that velocity is a vector quantity, it has magnitude as well as direction. Okay, so magnitude we know how to find out based on the formulas what I have told, that is R into omega, whereas how to find out the direction. How to find out the direction, Pa? The first case, how to find out the direction. So with respect to point O, your point A is going to make what type of rotation, Pa? With respect to O, your point A is going to make what type of movement? Please
Oscillation.
oscillation or rotation, pure rotation, whatever it may be, it is going to trace a path like this, correct or not? Okay, so your velocity is going to act in a direction tangential to this arc, or otherwise we can take perpendicular to the length. Both are correct. Okay, ஸோ இந்த ஆர்க்குக்கு ஒரு டேஞ்சன்ட் போட்டீங்கன்னா அந்த டைரக்ஷன்ல தான் உங்களோட வெலாசிட்டி ஆக்ட் ஆகும். ஓகே, ஆர் அதர்வைஸ் வி கேன் சே த வெக்டார் வில் பி ஆக்டிங் பர்பண்டிகுலர் டு த லிங்க். ஸோ இந்த டிகிரி இந்த ஆங்கிள் இந்த லிங்க்குக்கு 90 டிகிரி இருக்கும். ஆர் அதர்வைஸ் இந்த ஆர்க்குக்கு ஒரு டேஞ்சன்ட் போட்டீங்கன்னா அந்த டைரக்ஷன் ஆக்ட் ஆகும். போத் ஆர் கரெக்ட். ஸோ நவ் டெல் மீ, it will be acting along this direction or this direction. Which direction it is going to act? We know,
Anti-clockwise.
we cannot say anti-clockwise or clockwise. Your link is rotating anti-clockwise, but vector is towards this direction or this direction. It is going to act towards left hand side because your link is going to rotate in counterclockwise direction. So your velocity vector is going to be along this direction. Okay, let me draw it in green color. So your velocity vector should be along this direction, not this direction, because in the direction of act ஆயிட்டு link rotation in counterclockwise direction. So counterclockwise direction velocity should be along this direction. If it is clockwise direction, your velocity vector will be along this direction. Is it clear how to determine the magnitude as well as the direction of the vectors?
Yes, sir.
Okay, let us proceed with the problem so that you can understand in a better way. So now look at this problem. Graphical position of the links for the rock crushing mechanism is shown in figure. Determine the angular velocity and velocity of all the links. Velocity of all the links. The crank rotates at an angular velocity of 20 radians per second counterclockwise direction. The same diagram I have given here with some input data. So how to proceed? How to proceed this problem? First and foremost step, we should understand the need for velocity analysis. That is, எல்லா டேட்டாவும் கொடுத்துருக்காங்கன்னு first we need to check. So என்னென்ன சொல்லியிருந்தேன், எது கொடுத்துருக்கணும்னு சொல்லியிருந்தேன். What are the requirements?
Length.
First requirement is dimensions of all the links. All the links dimension given, correct or not? 60 mm crank dimension, and coupler 400 mm, rocker 180 mm, and frame 360 mm. All the dimensions are given. Okay, first condition, dimensions of all the links are given. So first condition is satisfied. What is the second thing? What is second requirement?
Sir,
Angular
arc-
rotation, sir.
Crank angle. So crank angle should be given. So இங்க வந்து crank angle எவ்வளவு கொடுத்திருக்காங்க, 90 degree கொடுத்திருக்காங்க. So it is given. Okay, second condition is also, second requirement is also given. Third one.
Sir, magnitude and direction.
Not magnitude and direction, the speed or input velocity of crank. Okay, or crank velocity, or at least one link koda velocity. Edo one kodutha kuda we can find out. Here the crank is given. So crank koda angular velocity, that is 20 radians per second in counterclockwise, it is given. So velocity of the crank is 20 radians per second in clockwise direction. Clockwise direction is given. So it is very comfortable. We can start the problem. To find out what? To find out what?
Velocity and angular velocity.
Velocity, angular velocity of what? So assume your frame is
All.
link 1, crank is link 2, and coupler is link 3, and rocker is link 4. What angular velocity you are supposed to find out?
all links.
Enapa?
All links.
Angular velocity of all other links. Because angular velocity of the crank is given, you can able to find out the angular velocity of the coupler, can able to find out the angular velocity of the rocker. Okay, எல்லாமே find out பண்ணிக்கலாம் at the end of the velocity polygon approach or relative velocity method, and velocity of all the links. Okay, எல்லா links ஓட we can find out, in the previous case we are able to find out the angular velocity. Now we can find out the linear velocity of all the links. For example, this particular point, in the point என்ன velocity கண்டுபிடிச்சிக்கலாம், இந்த particular pointsல என்ன velocity, this particular point and this particular point, இந்த 4 pointல main pointல என்ன velocity கண்டுபிடிக்கலாம். Moreover, in between, for example, this is the location where I want to find out velocity, this is the location where I want to find out the velocity. linear velocity. Okay, so everything can be obtained with the help of this approach. But primary thing we are able to find out now, we are going to focus on the angular velocity of the link 3 and 4 and the angular velocity, I'm sorry, linear velocity of the points here. Okay, this green color points. Okay, so these are all the things we are going to focus now. Now, what is the first step? We need to draw the what is the first step? What is the first step? We need to draw the configuration diagram. So, name for the diagram what we are going to draw now is configuration diagram, or we can call it as kinematic diagram. Kinematic diagram. Okay. What is in the configuration or kinematic diagram? What is in the configuration diagram or kinematic diagram? So here, if you look at this particular application, it is applicable for rock crushing mechanism. The rock clickliya, அது வந்து crush பண்றதுக்கு. So here you may have a hopper. இந்த இடத்துல rocks எல்லாம் போட்டுருவாங்க. So அது வந்து கீழே கிராவிட்டியில ஃபால் ஆகும். So due to the rotation of the crank, your rocker is going to make some oscillatory motion like this. So that it is a blade which is attached with the rocker is going to make an impact with your rock, that is rocks, so that it will be crushed into small particles. So that will be used for after sheathing, it can be used for civil applications for building construction. Okay, that is the major application of this particular rock crushing mechanism. So first in the application point of view, this mechanism is given. We need to isolate all other joints, all other things, and you need to only concentrate on the mechanism what you are going to discuss. அதை மட்டும் லைன் டயக்ராம் மாதிரி போட்டீங்கன்னா that is nothing but your configuration diagram or kinematic diagram. So if you look at this particular line diagram, it indicates what the application you are having, but without considering the rock crushing, everything, etc. Only mechanism மட்டும் focus பண்ணி வரைஞ்சிருக்கும். So what is the name for this particular hidden line? Name for this particular hidden line?
Frame, sir.
It is a frame. So we can indicate like this. It is frame. This one.
Crank.
It is crank. So see the original application image and relate what I have drawn. So what is this one?
Couplers.
Coupler, sir.
This one?
Rocker.
Rocker. Okay.
Rocker, sir.
So rocker அந்த பக்கம் இருக்கிற அந்த இதெல்லாம் நான் விட்டுட்டேன். Okay, I leave all the things. I concentrate only the mechanism what you are going to use it for. So அதை மட்டும் வரைஞ்சிட்டேன். So this is my configuration diagram. So how to draw the configuration diagram? It is not a simple line diagram. You need to draw it in accurate scales. ஓகேவா, என்ன ஸ்கேல் கொடுத்துருக்காங்களோ அந்த ஸ்கேல் மட்டும்தான் you need to use. Okay, I should draw the configuration diagram as per the dimensions which are given accurately. Okay, either you can reduce the scale or you can enlarge the scale depending upon the dimensions what they have given. இங்க பாத்தீங்கன்னா 180 mm 360 mm எல்லாம் கொடுத்துருக்காங்க. So it is not possible to produce all those things in your A4 sheet. So in that case you can reduce the scale. So 1:2 வரைஞ்சிக்கலாமா? Okay, because 360 mm paper கொண்டு வரது it is highly difficult. So scale வந்து you need to reduce here. So என்ன வரையறீங்களோ என்னென்ன dimensions இருக்கோ அது எல்லாமே half reduce பண்ணி you need to draw it. So what is the first step? Configuration diagram வரை இருக்கு. What is the first step? First வந்து இங்க frame வந்து இங்க ஒரு டாட் வச்சுக்கங்க. அடுத்த டாட் வந்து எவ்வளவு டிஸ்டன்ஸ்ல வைக்கணும்?
180 mm, sir.
180 mm, exactly. So this is your point. Let me denote this as point A and let me denote this point D. Okay, so the distance between point A and point D is 180 mm because we reduced the scale to 1:2. So 360 mm அப்படியே வைக்க தேவையில்லை. We can reduce 180 mm. But you need to write the scale without fail. Okay, என்ன scale யூஸ் பண்ணிருக்கீங்க சொல்லிடணும் இங்க on the left hand side or right hand side. Okay, next step. We need to draw the crank. Okay, what is the dimension of the crank?
30 mm, sir.
60 mm, reduced scale 30 mm. So we need to draw a line in the angle power, So with the frame, it should make 90 degree. Okay, va? So in the vertical 30 mm, you need to draw a line. So at the end of the line, you need to make a point that is B. So it indicates crank. Okay, so length on the 30 mm. So this is your frame. Next, we need to draw the coupler and rocker. Okay, so இது ரெண்டும் என்ன பண்ணோம், இதுக்கு angle கிடையாது, length மட்டும் தான் இருக்கு. So what you do is you need to take the center as B, and here the coupler dimension is 400 mm, correct or not? So the scale reduce பண்ணீங்கன்னா 200 mm. So B as center, 200 mm as radius, you make an arc. Okay, and D as center, and rocker dimension எவ்வளோப்பா?
90 mm, sir.
180 mm, reduced scale 90 mm. So D is center வச்சுட்டு you need to draw another arc for 90 mm radius. You will have this particular point. What is the name for this point?
C, sir.
C. Okay. So once you got the point C, you can connect C with B. C with B. What is the CB?
200 mm, sir.
Okay. Okay. It may be 200 mm. What is the name for this? It is coupler.
Yeah, coupler, sir.
Okay. If you connect C with D. Yes. If you connect C with D, what is the name for this?
Rocker, sir.
Rocker. Okay, so this is your kinematic diagram. Okay, this is the way you are supposed to draw the kinematic diagram or configuration diagram. Clear? So நீங்க சின்ன நார்மல் சின்ன டைமென்ஷன்ஸ் கொடுத்தாங்கன்னா அப்படியே என்ன ஸ்கேல் கொடுத்துருக்காங்களோ அதை அப்படியே வரைஞ்சிக்கலாம். பட் நீங்க யூஸ் யுவர் காமன் சென்ஸ், இட் இஸ் நாட் பாசிபிள் டு ப்ரொடியூஸ் இன் யுவர் A4 ஷீட். ஸோ 360 mm ஒரு பேப்பர் ஃபுல்லாக ஆக்குபை பண்ணிக்கும். So it is you can conveniently reduce the scale 1:2 இல்ல 1:4 as per the standard you can reduce. So இங்க யூஸ் பண்ற ஸ்கேல் இதோட விட்டுறணும், இதுக்கப்புறம் எடுத்துட்டு வரக்கூடாது. Okay, so this configuration is diagram is must. Okay, so the scale whatever you are using here இங்கே விட்டுறணும், இதுக்கப்புறம் போற velocity polygonக்கு இந்த scale யூஸ் பண்ணக்கூடாது. Okay, it is applicable only for drawing the configuration diagram. Is it clear? Are you able to understand how to draw the kinematic diagram or configuration diagram? Yes.
Yes, sir.
Okay.
Yes, sir.
Okay, let me proceed. So now only the chapter begins. Okay, so this is the configuration diagram what I have drawn. Now I'm going to find out the velocities of all the points. Okay, my primary objective is to find out the angular velocity of links 3 and 4. Okay, already 2 order angular velocity தெரியும். Now I'm going to find out the angular velocity of the link 3 and 4 and linear velocity of points B, C, linear velocity of all the points A, B, C and D. If you want, you can add further points in between any locations in the link, so that it is also possible to find out the velocities. But from problem perspective, so problem let me find out the velocity at point A, point B, point C and point D. So what indicates velocity? It is linear velocity. Okay, angular velocity omega. So angular velocity omega, linear velocity and the points determine பண்றது. Okay, so this point A, point B, point C and point D. So these 4 points I'm going. But angular velocity throughout the link, it is going to have the common angular velocity. Okay, angular velocity எடுத்துட்டீங்கன்னா the link complete it is going to rotate with some angular velocity, that is omega 3, because the link is 3. So let me denote it as omega 3. This is also omega 4. In the link எடுத்துட்டீங்கன்னா omega it is not going to change, but velocity linear velocity எடுத்துட்டீங்கன்னா I will have at this location I will have linear velocity, at this location I will have another velocity, at this location I will have a different magnitude of velocity, linear velocity. So linear velocity varies depending upon the orientation or position of the points where you are taking, but angular velocity is going to same throughout the link. Okay, so that's why I'm finding out the angular velocity of the link 3 and link 4 and the linear velocity at different points. Okay, now to start with, we need to understand some basic ideas about the velocities. So now tell me, what is the velocity of point A? Point A,
Zero,
linear
sir.
velocity. Exactly. So velocity at point A will be 0. Similarly, velocity at point D.
0, sir.
Yes. Why?
It is fixed, sir.
Fixed.
So no
It is
velocity.
fixed. It doesn't move. So rate of displacement with respect to time is going to be 0. So velocity will be 0 and thus acceleration also will be 0. So ரெண்டு பாயிண்ட்ல ஆல்ரெடி இமீடியட்டா பிடிச்சாச்சு. ஸோ கான்ஃபிகரேஷன் டயக்ராம் வரையறதுக்கு ஒரு 2 மார்க் கொடுப்போம். தென் வெலாசிட்டி ஆஃப் ஏ, வெலாசிட்டி ஆஃப் டி இமீடியட்டா லொகேட் பண்ணீங்கன்னா அதுக்கு ஒரு மார்க். Okay, you need to understand fixed point. Okay, there is no velocity. Okay, there is no linear velocity at fixed point. Okay, now what is our duty next? It is reduced. No, okay, linear velocity வந்து நான் பாயிண்ட் ஏ, பாயிண்ட் பி, பாயிண்ட் சி, பாயிண்ட் டில கண்டுபிடிக்கலாம்னு சொன்னேன். ஏலையும் டிலையும் ஆல்ரெடி நம்ம கண்டுபிடிச்சாச்சு. ஸோ இட் இஸ் 0. The remaining is linear velocity at point B and C கண்டுபிடிச்சா போதும், and angular velocity of link 3 and 4 கண்டுபிடிச்சா போதும். Because link 1க்கு it doesn't have any angular velocity. Correct or not? It is a fixed frame. It doesn't have any angular velocity. So I need to find out angular velocity of link 3 and link 4. ஏன்ப்பா link 2 கண்டுபிடிக்கலாம்? It is omega 2k கண்டுபிடிக்கலாம்.
Given, sir.
It is given. Okay,
Given,
it is
sir.
already given in the problem itself. With that only, it is possible to proceed the problem without knowing input velocity or any velocity, any one of the links velocity. It is not possible to proceed. Okay, wow. So that should be known. That is given. So omega 2 is given in the problem itself. Now we are going to find out velocity at point, linear velocity at point B and point C. How to proceed? Okay, so now I am going to consider only link AB. Okay, A being a link மட்டும் let me consider here. Okay, so this is my point A and this is my point B. Let me consider only the link AB. Okay, I am going to find out velocity at point B. அதனால I am going to consider only the link AB. Okay, so which is fixed point pa?
Yes.
Yes, sir.
அதாவது இந்த லிங்க் மட்டும் I have extrapolated, I have drawn here. Okay, is it clear?
Yes, sir.
Okay. Now with fixed point is A and the B point is going to rotate a pure rotation with respect to what? Fixed point A. Okay, the point B is going to rotate along this path which is traced in this circle. Okay, இந்த பாத்தை trace பண்ணும். பண்ணுச்சுன்னா with respect to point A, it is going to move along this path. Okay, now how to find out the velocity at point A? How to find out velocity of point A?
0, sir.
I'm sorry, velocity of point B. Velocity of point B எப்படி கண்டுபிடிக்கிறது? How to find out velocity of point B? நான் போன ஸ்லைட்ல சொன்னேன்.
Sir, we should use the formula, sir.
Yes, velocity of point B. Velocity of point B can denote like this. That should be equivalent to velocity of point A plus velocity of point B with respect to A.
Yeah. Yes, sir.
Correct or not?
Yes, sir.
Velocity of point B வேணும்னா velocity of point A தெரிஞ்சிருக்கணும். Then velocity of point B with respect to A போட்டீங்கன்னா you will be getting velocity of point B. Okay, so now tell me what is velocity of A?
0, sir.
Yes, it tends to 0 because it is a fixed point. So velocity of point B is equivalent to velocity of B with respect to A.
Yeah.
Okay, now tell me how to find out velocity of B with respect to A. We know how to find out velocity of B with respect to A. Velocity of point B with respect to A. எப்படிப்பா கண்டுபிடிக்கிறது? Formula. What is the formula?
Sir,
R omega, sir.
R omega, sir.
Very good. R omega. R omega, omega 2 or omega 3 or omega 4?
Omega 2, sir.
Omega 2.
sir.
Please make a note because so many omegas are there. So clearly you need to mention omega 2. What is R here?
60 mm. sir.
60 mm.
First tell me the caption AB. Correct or not? ஆறுங்கிறீங்க
Yes, sir.
AB
AB.
because we consider only the link AB. So AB into omega 2.
Omega 2, sir.
That is AB is 60 mm. ஸோ இங்கே வந்து ஸ்கேல் டவுன் பண்ணிடக்கூடாதுப்பா. இங்கே வந்து ஒரிஜினல் டைமென்ஷன் இருக்கும். வரையருக்கு மட்டும்தான் ஸ்கேல் டவுன். இங்கே வந்து ஸ்கேல் டவுன் பண்ணி மேக்னிடியூட் போட்டுறக்கூடாது. ஓகே. ஸோ AB is 60 mm into omega 2. How much?
90, sir.
It is not 90. 20 radians per second.
20. Oh, yes, sir.
Okay. It is omega 2 is 20 radians per second. It is given in the problem itself. So 60 into 20. How much?
1200.
1200 unit வந்து mm per second. Okay, so what is this actually? Velocity of point B. Okay, or otherwise we can say it is absolute velocity, correct or not? Because we are finding out the velocity of B with respect to a fixed point, it is absolute velocity. So
Yes,
velocity
sir.
of point B. So அடுத்த work over. So velocity of A கண்டுபிடிச்சாச்சு, velocity of D கண்டுபிடிச்சாச்சு. Now velocity of B is also over. That is magnitude is 1200 mm per second. Okay, how to find out the direction part? Magnitude தெரிஞ்சிச்சு. Since velocity is a vector quantity, we know magnitude is 1200 mm per second with respect to A. That is point B's velocity with respect to A is 1200 mm per second. How to find out the direction? How to find out the direction? So it is perpendicular to the link, or otherwise the tangent which is drawn to the path traced by the curve. Okay, anything you can take. Normally, let me insist the students to take the vector which is perpendicular to the link. Okay, so எப்படி எடுப்போம்னா இந்த லிங்க் AB இருக்கு இல்லையா, AB லிங்க்குக்கு பர்பெண்டிகுலரா ஒரு லைன் வரைஞ்சிடணும். Okay, so this is your velocity vector. In which direction it is going to act?
Clockwise.
Your link is rotating in clockwise direction. Okay, clockwise னு சொல்லிட்டாங்க ப்ராப்ளத்திலேயே. So velocity vector எப்படி இருக்கும்பா? Either in the direction or in the direction?
Towards left, sir.
Yes, towards left. So we can draw this towards left because it is
Left, sir.
towards it is rotating clockwise. So your velocity vector is also going to act along towards left. Is it clear?
Yes,
Okay.
sir.
So velocity of point B கண்டுபிடிச்சாச்சு, அதோட I'm sorry magnitude கண்டுபிடிச்சாச்சு, அதோட directionம் கண்டுபிடிச்சாச்சு. Now we are able to produce all these findings in velocity polygon. So velocity polygon கண்டுபிடிக்கணும். Velocity polygon கண்டுபிடிச்சீங்கன்னா the problem will be over. It is possible to find out the velocity of all other points. Okay. Now how to start to draw the velocity polygon? Okay, once we know velocity of simple points, then immediately we need to draw it in velocity polygon. Okay, so velocity polygon வரையறதுக்கு முன்னாடி we need to use some scales. Okay, so wait. So let me take the origin. Okay, origin point which is zero magnitude of velocity. Okay, எந்த பாயிண்ட்ல இப்ப velocity வந்து zero. So this is the velocity polygon. Okay, velocity polygon நான் வரைய போறேன். ஓகே, வெலாசிட்டி பாலிகன் வரைய போறேன். அதுக்கு வந்து ஆரிஜின் எடுக்கணும். ஆரிஜின் வந்து இந்த ரெட் கலர். எந்த பாயிண்ட்ல வெலாசிட்டி ஜீரோ?
A and D.
Okay. Okay, that both A and D are supposed to be taken as reference. Those pointsல வந்து velocity வந்து zero. Okay, so in the red color indicates A and D point where your velocity will be zero. Now second step, I am going to draw. Someone unmute பண்ணிருக்காங்கப்பா, யாருன்னு பாருங்கப்பா. It is making noise to me. Please mute that. Now I am going to draw the velocity of point B. Okay, as I know velocity of point A and D in the problem itself, because those are fixed points, so velocity is zero. Now I am going to draw the velocity of point B. Velocity of point B எப்படி வரையணும்? We are drawing velocity polygon. It is a velocity vector in vector approach. Okay, how to draw the velocity of point B? So we know the direction when we know the magnitude. Both are known. It is very simple to proceed. Okay, direction in the direction pa point A லந்து
Clockwise, sir.
Not clockwise. Clockwise வரைய முடியாது. In the direction. The red color indicate பண்ணிருக்கு இல்லையா?
Left side.
Okay,
sir.
Left side.
Yes, towards left side. நீங்க என்ன பண்ணனும்னா இந்த AB க்கு AB configuration diagram வரைஞ்சிருப்பீங்க. அதுக்கு perpendicular-ஆ ஒரு line you need to draw from point A in the velocity polygon. Okay, So check whether it is correct or not. Is it perpendicular to AB? Configuration diagram இருக்கிற AB க்கு perpendicular இருக்கப்பா?
Yes, sir.
Yes. And it is acting towards left arm because your crank is rotating clockwise direction. So as I told in this case, it should act along left hand direction. Okay. Is it correct?
Yes, sir.
Okay. Now tell me, what is the length you are supposed to draw? That is very important. We know the direction. Now, magnitude வந்து 1200 mm சொல்லிட்டேன். Velocity of B வந்து represent பண்றதுக்கு 1200 mm per second சொன்னோம். But normally we are using our normal scale. அதுல எப்படி represent பண்ணலாம்? ஓகே. ஸோ அதுக்கு என்ன பண்ணா அதுக்கு இங்கே வந்து வேற ஸ்கேல் எடுக்கணும். அப்போ கான்ஃபிகரேஷன் டயக்ராம்க்கு ஒரு ஸ்கேல் போட்டிருப்பீங்க, அந்த ஸ்கேலை வந்து அதோட விட்டுறணும். இப்போ வெலாசிட்டி பாலிகனுக்கு வரைய போற ஸ்கேல் வந்து இட் இஸ் டிஃப்ரெண்ட். ஓகே. ஸோ வெலாசிட்டி பாலிகன்ல ஒரு எம்எம் வச்சீங்கன்னா தட் இண்டிகேட்ஸ் 50 mm per second. அப்படின்னு நீங்க யூ கேன் டேக் யுவர் கன்வீனியன்ஸ் ஸ்கேல். நீங்க 1 mm ஈக்குவல் டு 25 mm per second வச்சுக்கலாம், 1 mm ஈக்குவல் டு 100 mm per second வச்சுக்கலாம். இட் இஸ் டிபெண்டிங் அப்பான் யூ. ஆல் ஆஃப் யூ ஆர் கோயிங் டு கெட் த சேம் வேல்யூ ஆஃப் வெலாசிட்டி. ஓகே. நான் சொல்ற மாதிரி ப்ரொசீட் பண்ணீங்கன்னா வில் பி கெட்டிங் த சேம் ஃபைனல் ஆன்சர். பட் த ப்ரொசீஜர் மட்டும் நீங்க ஸ்கேலுக்கு தகுந்த மாதிரி மாத்திருப்பீங்க. பட் இந்த ப்ராப்ளத்துல லெட் மீ டேக் 1 mm இந்த ஸ்கேல், நார்மல் ஸ்கேல், லீனியர் ஸ்கேல், வாட் எவர் யூ ஆர் யூசிங், it indicates 50 mm per second. Now tell me how many mm you are supposed to keep for giving the velocity of B, that is 1200 mm. நீங்க இந்த லென்த் போடுறதுக்கு வந்து 1200 mm போடணும் அப்படின்னா நீங்க ஸ்கேல் எவ்வளவு வைப்பீங்கப்பா?
24 mm, sir.
24 mm, sir.
24 mm. 1200 divided by 50 போட்டீங்கன்னா எவ்வளவு வரும்பா?
24.
24 கரெக்டா? 24 mm லென்த் வச்சுக்கணும். ஸோ இந்த ரெட் கலர் வெக்டார் வந்து 24 mm இருக்கணும் டுவர்ட்ஸ் லெஃப்ட் ஹேண்ட் சைட். டைரக்ஷன் மாறி இருக்கக்கூடாது பிகாஸ் டைரக்ஷன் யூ ஆர் டேக்கிங் ஃப்ரம் த கான்ஃபிகரேஷன் டயக்ராம் அண்ட் மேக்னெட் யூ ஆர் டேக்கிங் ஃப்ரம் த கால்குலேஷன். ஓகே. ஸோ இந்த வெக்டாரோட லென்த் வந்து 24 mm. ஸோ 24 mm இஸ் இண்டிகேட்டிங் 24 இன்டூ ஸ்கேல் எவ்வளவுப்பா? 50 mm per second. How much? 1200 mm per second. Okay, so in the 24 mm it is indicating 1200 mm per second velocity. That is velocity of, what is this actually? What is velocity? It is velocity of point B with respect to A. That indicate பண்ணுது. That is 1200 mm per second. What is end point? What is end point pa?
B, sir.
B. Very good. So end point is B. AD la வந்து velocity 0 and B, velocity of B is acting perpendicular to the link AB and magnitude is 1200 mm per second and it is acting perpendicular to the link AB towards left hand side because it is crank is rotating clockwise direction. And this vector is indicating velocity of B with respect to A. Any doubts up to this?
No, sir.
Any doubts in making scales? Scale எப்படி இருக்குன்னு தெரியலையா உங்களுக்கு? புரிஞ்சுதா? ஸ்கேல் வந்து நீங்க இந்த ரெட் கலர் லைன்ல வரைஞ்சிருக்க ஒவ்வொரு எம்எம்மும் 50 mm per second இண்டிகேட் பண்ணுது. ஸோ நீங்க 24 mm வச்சீங்கன்னா இட் இஸ் இண்டிகேட்டிங் 24 into 50 1200 mm per second. பிகாஸ் நீங்க ஸ்கேல் ஒரு mm ஈக்குவல் டு 1 mm per second கூட வைக்கலாம். பட் யூ நீட் டு ட்ரா 1200 mm லைன். இட் இஸ் நாட் பாசிபிள். ஸோ ஸ்கேல் வந்து வி நீட் டு ரெடியூஸ். ஓகே. So 1 mm in the scale, it indicates 50 mm per second. So 24 mm you need to draw. But Vareda 24, but it is indicating that what? 1200 mm per second velocity. That is velocity of B with respect to A. Is it clear? Now we got velocities for 1 point. 3 points we got. Any doubts up to this?
No, sir.
Okay. Shall I proceed?
Yes, sir.
Yes. So first step we got velocity of point A and B. Okay, so A and B, and here velocity of B கிடைச்சிச்சு. So it indicates velocity of B with respect to A, that is 1200 mm per second. Scale is 50 mm per second we use. Now what is the next step? What is the next step?
Sir, we should find velocity for B and
Velocity of
C, sir.
yes, velocity of point C என்னங்கிறத கண்டுபிடிச்சிட்டோம்னா linear velocity எல்லாமே over. Okay, because A la கண்டுபிடிச்சாச்சு, B la over, D la over. Then finally we need to find out the velocity of point C. Why did we started with velocity of B pa? Why we started velocity of, why can't D? I'm sorry, why can't C?
சார் நமக்கு ஒமேகா 2 தான் தெரியும்.
Omega 2 is known, so it is possible to find out the velocity of B only. அதுக்கப்புறம் தான் C கண்டுபிடிக்க முடியும். எடுத்தோடனே C போக முடியாது because we don't know angular velocity of the link 3 and angular velocity of the link 4. Both are unknown, so it is not possible to find out the velocity of C at the initial stage itself. That's why we started to find out velocity of point B, because your omega 2 is known in the problem itself. Okay, now we need to find out the velocity of C. Okay, so now I'm going to consider only the link BC. What is BC pa? Link BC எங்க இருக்கு pa? What is the length it is? What is the length of link BC? 400 mm. Okay, 400 mm. For finding out the velocity of C, I mean first I'm considering the link BC. Okay, so அதோட orientation இப்படி இருக்கா? Link BC ஓட orientation இப்படி இருக்கு.
Yes, sir.
Okay, so what is this point? It is your point B, and this point is your C. Okay, so for finding out the velocity of C, so time being you need to keep the B point as fixed. Okay, because with respect to B only your point C is going to rotate. Okay, so time being we need to keep the floating point as B. Okay, with respect to B only C is rotating. So அந்த மாதிரி வச்சுக்கிட்டீங்கன்னா, okay, now tell me how to find out the magnitude of velocity of point C with respect to B.
Sir, VB, sir, plus
Velocity of B plus
velocity of C in respect to B.
to B. போட்டீங்கன்னா you will be getting. Okay, now what is velocity of B?
0, sir.
Yes, time being we assumed that it is fixed. Okay, so it tends to 0. Now what is, how to find out velocity of C with respect to B?
Sir, R omega 2.
Sir,
Sir.
R omega 3.
So
R omega 3.
velocity of C with respect to B is R into omega 3. Because your link 3 is rotating with the angular velocity of omega 3. Correct or not? So R into omega 3. What is R?
400 mm.
400 mm. Omega 3 known or unknown?
Unknown, sir.
Unknown. So you keep it as it is. Okay, so velocity of C with respect to B is equivalent to 400 into omega 3. Correct or not?
Yes, sir.
Once you know omega 3, you are able to find out what is the magnitude of this one. But we don't know omega 3, so you retain as it is 400 omega 3. Okay, so in which direction it is acting? Your omega 3 is rotating along this direction. Which direction it is rotating? I'm sorry, acting. This velocity. Whenever I ask this question, I should receive answer from immediately from you. Okay, you should not hesitate to tell the answer.
Both directions.
Yeah, we don't know the direction, so time being என்ன பண்ணலாம், இந்த மாதிரி போட்டுக்கலாம். கரெக்டா?
Yes, sir.
That is perpendicular to the link. Perpendicular to the link BC. Okay வா? BC க்கு perpendicular இருக்கும், but we don't know along this direction or this direction which is acting. So நீங்க என்ன பண்ணணும், ரெண்டு டைரக்ஷனையும் போட்டுக்கங்க time being. Okay, so your velocity of C is going to act along, velocity of C with respect to act along this direction. Okay, but in the line, red color line la தான் இங்கே somewhere இருக்கு, but we don't know where it is. Okay, so it is indicated like this. Okay, so you draw at point B. Okay, along this direction, along this direction. The red color direction எதுப்பா? The red color எதை indicate பண்ணுதுப்பா? Velocity of C with respect to B. Okay, but you draw an infinite line which is perpendicular to the link BC. So BC, link BC பாருங்கப்பா configuration diagramல அதுக்கு perpendicular இருக்க அந்த vector.
Yes, sir.
It should be perpendicular to the link BC. அந்த direction எடுத்துக்கணும், but we don't know along this direction or this direction. So infinite மட்டும் போட்டுட்டு விட்டுருங்க. let me tell how to find out. Okay, so your C, okay, your C is going to lie, the C is going to lie along this direction. கண்டிப்பா அந்த Cங்கிற பாயிண்ட் வந்து velocity of Cங்கிறது இந்த லைன்ல தான் இருக்கும் somewhere. Okay, we are able to find out after completing this problem. Okay, any doubts up to this?
No, sir.
Okay, next velocity of point C can also be obtained with considering the link CD also, correct or not?
Yes, sir.
Okay, அதாவது velocity of point C can be obtained with respect to B. The previous step what we proceeded, அதுக்கு இந்த red color vector கிடைச்சிருக்கு. And velocity of point C can also be obtained with respect to the absolute point D. D பொறுத்தும் velocity of C கண்டுபிடிக்கலாம். அதுக்கு என்ன பண்ணணும் பார்க்கலாம்? We need to consider only link CD.
CD.
Okay, link CD மட்டும் consider பண்ணுங்க. Okay, which is fixed point?
D, sir.
Yes, your
D,
D
sir.
is this one. Okay, this is your D and this point is your C. Okay, what is the length of DC?
180.
180 mm.
180, sir.
Okay, now tell me how to find out the velocity of point C with respect to D.
Sir, velocity of C.
Velocity
Sir,
of point
velocity of
D plus velocity of point D with respect to C.
D with C, sir.
Okay, so what is velocity of D, pa?
0, sir.
0, sir.
So it tends to 0. Now we can able to find out velocity of, what is velocity of D with respect to C?
R omega
Sir,
R into omega
4.
4.
because this link is going to rotate with the angular velocity of omega 4. Okay, so it indicates omega 4. What is R?
180, sir.
180 mm. Omega 4 தெரியாது. It is unknown, correct or not?
Yes, sir.
Keep it as it is. So velocity of C with respect to D can be retained as it is 180 into omega 4. So in which direction it is acting, pa? In which direction it is acting? Perpendicular to the link CD. That's all. Direction கேட்டாலே okay va? Direction கேட்டாலே it should be acting perpendicular to the link CD. Okay, link CD எங்க பா இருக்கு? இங்க இருக்கு. Okay va? Link CD க்கு perpendicular-னா இந்த direction. Okay? Link CD க்கு perpendicular that can be represented in the kinematic diagram also. அது எங்க வரையணும்பா? Velocity polygon-ல you need to draw the same thing, but where you start? இந்த blue color vector எங்க பா வரையணும்? D ல இருந்து ஆரம்பிக்கணும் because we are finding out what? Velocity of C with respect to D. Okay, so இந்த vector வந்து இங்க போட்டு D ல இருந்து போட்டீங்கன்னா okay, you will be getting this. So இந்த blue color vector வந்து link CD க்கு perpendicular இருக்கப்பா?
Yes, sir.
Yes. So வரைஞ்சாச்சு.
Yes.
Now tell me what this green color vector is indicating. What this green color vector is indicating? Velocity of?
AB, sir.
Yes, velocity of B with respect to A. Right or not? So this is your point B. This is your point B. This is your point B. C. Okay.
Yes,
Am I
sir.
right or not? The intersection of the red color vector and the blue color vector will give your point C.
C.
Okay வா? இப்போ உங்களுக்கு தெரிஞ்சிச்சு. நான் சொன்னேன் C வந்து along this line தான் இருக்குன்னு சொல்லிட்டேன். Okay. இங்கேயும் பாத்தீங்கன்னா இந்த வெக்டரும் பாத்தீங்கன்னா that is if you consider the link CD, இந்த வெக்டரும் பாத்தீங்கன்னா இன்ஃபினிட்டா தான் இப்படி போயிட்டு இருந்திருக்கும். We don't know where it is acting. So the intersection of this red color vector and blue color vector will give your point C. Okay. Now what this red color vector is indicating? Velocity of?
Velocity of C, sir.
Velocity of B
Point
with respect
to B. Okay, it is a relative velocity because B is also moving point. So it is a relative velocity. Now tell me what is this blue color is indicating?
Sir, velocity of D in C, sir.
No, velocity of?
velocity of C with respect to
E
D,
with
sir.
respect to D. Correct. Please try to understand what we have proceeded. Okay, நம்ம இதுல என்ன பண்ணிருக்கோம்? D fixed C தான் கண்டுபிடிச்சிருக்கோம். So velocity of C with respect to D எதை பொறுத்து கண்டுபிடிச்சோமோ அது left hand side வரணும். Okay. Is it clear how to draw the velocity polygon?
Yes, sir.
Okay, now how to find out the velocity of point C now? Point தான் கிடைச்சிருக்கு இப்போ. How to find out the velocity of C? Can anyone respond? How to find out the velocity of C? Am I audible?
Yes, sir.
Point C ஓட velocity எப்படிப்பா கண்டுபிடிக்கலாம்? Best approach is to take from the velocity polygon. Okay, நீங்க பாலிகன் இந்த மாதிரி போட்டிருப்பீங்க இல்லையா? பாலிகன் போட்டிருப்பீங்க, இந்த லென்த் எடுத்துக்கோங்க. Okay, இந்த லென்த் மெஷர் பண்ணீங்கன்னா you will be getting some dimensions. Correct or not?
Yes, sir.
Okay, இது எதை இண்டிகேட் பண்ணுது? velocity of C with respect to B. Correct or not? அதான் இண்டிகேட் பண்ணுது. So velocity of C with respect to B something ஒரு டைமென்ஷன் வருது into எதால மல்டிப்ளை பண்ணணும்?
50 sir.
50 ஆல மல்டிப்ளை பண்ணீங்கன்னா you will be getting the velocity in terms of what?
Millimeter per second.
Millimeter per second.
ஓகே, இப்போ பாலிகன் எடுத்துக்கோங்க. பாலிகன்ல இருக்கிற லென்த்தை மெஷர் பண்ணுங்க. அந்த லென்த் இன்டு ஸ்கேல். ஓகே, திஸ் இஸ் இண்டிகேட்டிங் யுவர் ஸ்கேல். அதால மெஷர் பண்ணீங்கன்னா you will be getting velocity of C with respect to B in terms of mm per second. Now tell me how to find out velocity of C with respect to D. எந்த மெஷர்மெண்ட் எடுக்கணும்ப்பா? velocity of C with respect to D.
Blue line, sir.
Yes, this blue line. பாலிகன்ல இருந்து எவ்வளவு மெஷர்மெண்ட் வருதோ மெஷர் பண்ணிட்டு அது இங்க போட்டுக்கோங்க. into 50 that is equivalent to போட்டீங்கன்னா எவ்வளவு வரும்? some velocity per mm per secondல கிடைக்கும். Is it clear?
Okay, sir.
So velocity of B already we know the magnitude, and velocity of C ரெண்டு வழியில கண்டுபிடிக்கலாம். ஒன்னு velocity of C with respect to B, that is called as relative velocity. It is called relative velocity because you are finding out the point C with the movable point. B is also a movable point, so it is called relative velocity. And we are finding out the velocity of point C with respect to absolute also. With respect to fixed point, it is called absolute velocity. Absolute velocity. So both are possible. Okay. Now how to find out the angular velocity of the link 3 and 4? How to find out the angular velocity of the link 3 and 4?
Sir, we should apply in the formula, sir.
Yes. Already ஒரு formula வச்சிருந்தோம் இல்லையா? What is
Yes,
formula?
sir.
What is formula? Velocity of C with respect to D. அப்படின்னு ஒரு formula இருந்துச்சு இல்லையா? That is equal to how
Yes,
much?
sir.
180 into omega 4.
Omega 4.
இதை வச்சு omega 4 கண்டுபிடிக்கலாம். Then அதுக்கு முன்னாடி ஒரு formula போட்டோம் இல்லையா? What is the formula? Velocity of
Velocity of
C with respect to B
B, sir.
400 into omega 3.
Omega 3. Yes, sir.
இந்த ஃபார்முலா ரெண்டு ஃபார்முலா எடுத்துக்கோங்க. ஃபர்ஸ்ட் லெட் மீ ஃபைண்ட் அவுட் த angular velocity of the link 3 followed by angular velocity of the link 4. Now tell me, in the formula, it is not formula, it is derived from the previous velocity vector. இதுல எதுக்கு unknown actually?
Omega, sir.
Omega 3 is unknown. அத கண்டுபிடிக்கணும். 400 is a constant. What is velocity of C with respect to B? What is velocity of C with respect to B? Where we can take this?
Sir, absolute velocity இருந்து.
இல்லப்பா, velocity of
Polygon ல இருக்கு, sir.
it is taken from the polygon.
Polygon.
Polygon ல எங்க இருக்கு? Okay, this one. Correct? This is the velocity of C with respect to D.
Yes, sir.
So அதை இங்க substitute பண்ணீங்கன்னா you will be getting omega 3. Direct substitute பண்ணலாமா?
பண்ணலாம், sir.
பண்ணக்கூடாது. ஏன்னா அதுல into scale multiply பண்ணி தான்
ஏழு
பண்ணணும். Okay, so
Okay.
CB velocity polygon la CB multiplied by 50 will be equivalent to what? 400 into omega 3. Okay, CB எவ்வளவு வருதோ அது இங்க எழுதிக்கோங்க. ஃபார் எக்ஸாம்பிள் இங்க பார்க்க போனா அது வந்து இது வந்து 24 mm வந்துச்சா கிரீன் கலர் வெக்டார்.
Yes, sir.
Yes, sir.
இது வந்து அதை விட கம்மியா இருக்கும், ஒரு 6 mm 7 mm வரும் போல. அது எவ்வளவு மெஷர் பண்ணி வருதோ அதை போட்டு சப்ஸ்டிட்யூட் பண்ணீங்கன்னா you will be getting omega 3. omega 3 இங்கிறது is nothing but angular velocity of the link 3 in radians per second ல கிடைக்கும். Whatever quantity you are obtaining definitely should be associated with unit without fail. Okay, similarly velocity of C with respect to D is equal to 180 omega 4. இங்க இருந்து எடுத்துக்கலாம். So what is velocity of C with respect to D pa? Or where we can take it?
Sir, CD absolute velocity ல எடுக்கலாம்.
From the velocity polygon,
Polygon.
blue color vector. Okay, so blue color vector ஓட length எவ்வளவு வருதுன்னு எழுதிக்கோங்க. That is C into D. It is from velocity polygon. Okay, into scale 50, that is equivalent to 180 into omega 4. What is CD? CD எங்க இருந்து மெஷர் பண்ணுவீங்க? பாலிகன்ல இருந்து மெஷர் பண்ணிக்கணும். Okay,
Sir.
it is taken from the polygon. So similarly, it is also CD can be taken from the polygon. So polygon எவ்வளவு length வருதோ அதை மெஷர் பண்ணி into 50 ல போட்டீங்கன்னா that is equivalent to 180 into omega 4. So omega 4 is equal to some magnitude கிடைக்கும், that is equivalent to radians per second. Okay, omega 4 கிடைச்சிருச்சு. This is simple.
Yes, sir.
Okay, so you need to have the practice, otherwise it is not possible. So it is very simple problem. It is the most simple problem. Okay, we are having 6 links, 10 links, 8 links, இந்த மாதிரி நிறைய links இருக்கும், but those are all complex problems. Very basic fundamental problem is consisting of four-bar mechanism. So you need to understand the concept clearly for proceeding or finding out the velocity. So one more thing. So we know how to find out the velocity of point B. We know how to find out the velocity of point C, B, A, etc. That is linear velocity. And we know how to find out the angular velocity of the links 3 and 4. Okay, இதெல்லாமே கண்டுபிடிச்சிட்டோம். Suppose if I want to find out the velocity at a particular point E. Okay, so I have a point E. Let me here denote it as point E. So point E is DE is equivalent to 120 mm. Okay, where is D? It is a frame. E is here. So DE ingiradhu it is 120 mm distance la irukku. So how to find out the velocity of point E? How to find out the velocity of point E?
120 into omega 4, sir.
120 into omega 4. So here we need to use the proportionality ratios. Okay, for example, D, C and E all are in a straight line, correct or not? In configuration diagram, okay, point D, point E and point C எல்லாமே என்னது straight line ல இருக்கு. Similarly, velocity polygon லையும் இப்படி தான் இருக்கும். D, E and C will be in the same straight line. So in the D அப்படின்னா இது C அப்படின்னா your point is going to lie somewhere here. Okay, but அதான் கண்டுபிடிக்கணும். ஸோ அதுக்கு தான் ப்ரொபோர்ஷனாலிட்டி இது யூஸ் பண்ணிக்கலாம், மெத்தட் ஆஃப் ப்ரொபோர்ஷன்ஸை யூஸ் பண்ணிக்கலாம். ஸோ அதுக்கு வந்து let me use the relationship that is DE divided by DC. What is mean by DE by DC pa? What is mean by DE by DC?
Change in
CD, sir.
These are all dimensions using configuration diagram. Okay, that can be taken from the configuration diagram. Okay, what is DE?
120.
120 mm divided by DC 180 mm. That should be equivalent to the corresponding ratios in polygon, velocity polygon. So அதுக்கு வந்து small letter, lower case, let me use small de divided by small dc. So small letters indicate it is taken from the polygon and capital letters indicate that it is taken from the configuration diagram. So we are using the proportion concept for finding out the unknown thing. So we know what is DE, what is DC. What is small d, small dc, pa? How to find out small de and small dc? D இங்க இருக்குப்பா polygon. Small d, small dc can be taken from the polygon. Okay, அது எங்க இருக்கணும்? Small d இங்க இருக்கு, small c இங்க இருக்கு. So அதோட length. ஓகேவா? டினாமினேட்டர்ல போடணும். Is it clear? That is this dimension. Clear or not?
Yes, sir.
Okay, the small capital DC ki corresponding small d DC that we can taken from the polygon. And DE, is it known or unknown?
Unknown.
Unknown. So you keep it as it is. Okay, so DC தெரியும், some magnitude தெரியும். So unknown வந்து DE. இதுல இருந்து கண்டுபிடிச்சிக்கலாம். அந்த கண்டுபிடிச்சீங்கன்னா எவ்வளவு வருதோ அந்த D ல இருந்து மெஷர் பண்ணி இங்க ஒரு டாட் வச்சிட்டீங்கன்னா you will be getting point E. That's all. Is it clear? So other than joints, any other points கண்டுபிடிக்க சொன்னாங்கன்னா you need to use this particular concept. Ratio, proportions ratio use பண்ணி you need to find out the velocities of all other points other than joints. Joints கேட்டாங்கன்னா நான் என்ன முன்னாடி சொல்லி கொடுத்தேனோ அந்த மாதிரி போடணும். Other than joints கேட்டாங்கன்னா we need to proceed like this. Is it clear?
Okay, sir.
Okay. Now
Yes, sir.
what is indicating this particular thing? This one, velocity of point E with respect to D. Okay, velocity of point E with respect to D. Is it clear? No
Yes, sir.
response.
Yes, sir.
It is indicating velocity of point C with respect to, velocity of point E with respect to D. Okay. Now tell me how to make the directions for velocity of C with respect to B in velocity polygon. The arrowhead போடணும்பா எப்படி போடணும்? Which is origin. எதை பொறுத்து எது ரொட்டேட் ஆகுதுப்பா? This red color vector எடுத்துக்கோங்க. Red color vector எடுத்துக்கோங்க. எதை பொறுத்து எது ரொட்டேட் ஆகுது? C is rotating with respect to B, correct or not?
Yes, sir.
Yes, sir.
C is a fixed point, origin point, about which C is rotating. So your arrowhead should point out C. Okay, va? So it indicates that velocity of C with respect to B. Okay. Similarly, inga arrowhead put enna meaning pa? I'm indicating this arrowhead. What is the meaning for this? Velocity of
E is
C with respect to D. Okay, நம்ம அப்படிதான் கண்டுபிடிச்சோம். Velocity of C with respect to D. The blue color vector இங்க என்னது? It is indicating velocity of C with respect to D. அப்ப C நோக்கி உங்களோட arrowhead இருக்கணும். C is the rotating point, whereas D is the origin about which your C is rotating. Is it clear?
Yes, sir.
Yes, sir.
Okay. Now tell me what is the direction of your angular velocities of link 3 and 4? We know how to find out the angular velocity of link 3 and 4. What is the direction? Angular velocity என்ன எப்படி direction mention பண்ணும்பா? Crank எப்படி mention பண்ணிருக்காங்க?
clockwise.
Clockwise or counterclockwise அந்த மாதிரி தான் mention பண்ணணும். Okay. Now tell me how to find out your angular velocity direction of link 3. Okay, you consider link BC alone. Okay, B and C, then link 3. So B is your fixed point. Okay, your C is the rotating point about point B. Okay, where the vector is moving. Okay, that BC vector is moving. This red color vector. இப்படிதான்ப்பா போகுது. Am I right or not? Previous slide I have drawn. Okay, this direction. So you draw this vector in this point C. Now tell me about point B. C is rotating in which direction?
Left side.
It is not left side or right side. It should be mentioned in clockwise or counterclockwise. Okay, you consider the link and take the vector from the polygon and you place it on the C. Now tell me about point B. In which direction C is rotating?
Clockwise, sir.
Clockwise, sir.
C பொறுத்து இப்படி இழுத்தா எப்படி ரொட்டேட் ஆகும்? Clockwise தானே? So you find out the magnitude from the formula and indicate it is clockwise direction or write it like this, clockwise direction. So angular velocity கண்டிப்பா directions எழுதணும், counter clockwise or clockwise னு எழுதணும். Okay. Now tell me how to find out the angular velocity of the link 4. How to find out the angular velocity of the link 4. அதுக்கு எந்த link consider பண்ணணும்பா?
CD, sir.
CD. Okay, your CD is like this. This is your point C and this is your point D. So this is your point D and this is your link 4. It is rotating like this. You need to find out the direction of the angular velocity of link 4. Okay. So for that you need to consider this link and which vector you are supposed to take for this. Which vector you are supposed to take? From the
Blue.
bottom. This blue
Blue.
color. Okay, this indicates velocity of C with respect to D. It is moving like this, correct or not? It is moving like this. Take this vector and place it in your velocity polygon. Okay, so இங்க வச்சீங்கன்னா இப்படி போகுமா? Okay, right or not? இந்த வெக்டார் கொண்டு வந்து அப்படியே இந்த பாயிண்ட் C ல வச்சிருங்க. வச்சீங்கன்னா about point D, your C is rotating in which direction?
Clockwise.
Yes, about this point D, your C is rotating clockwise direction. So you, after finding out the magnitude of angular velocity of the link 4, you indicate it is rotating in clockwise direction. So it is also essential to find out without fail. Is it clear? So magnitude எப்படின்னு மட்டும் சொல்லியிருந்தாப்லையா, இப்போ வந்து directionும் you are supposed to find out. Any doubts?
No, sir.
Okay. You just go through the video. Today I will upload all the videos related to the velocity analysis. You go through the video, then you practice on problem. Okay, taking from the textbook or anywhere else. You refer on problem and you proceed using roller scales. Okay, இது வந்து இந்த பர்பெண்டிகுலருக்கு அதுக்கு இது போடுறதுக்கு எல்லாமே வெக்டர் போடுறதுக்கு எல்லாமே ரோலர் ஸ்கேல் யூஸ் பண்ணோம். அதுக்கு ரிலேட்டடாக ஒரு வீடியோ நான் அனுப்பிச்சி விடுறேன். ஸோ அதை பார்த்தீங்கன்னா யூ ஆர் ஏபிள் டு அப்ரிஷியேட் ஹவு டு யூஸ் the roller scales for drawing the perpendicular lines for a links. Okay, vector போடும்போது லிங்க்குக்கு பர்பெண்டிகுலர் போடணும்னு சொன்னேன், அது எப்படி போடணுங்கிறது அந்த வீடியோவில் கிளியராக சொல்லியிருப்பாங்க. So since we are taking from the virtual mode, it is not possible to show how to use the roller scales for mini drafter. You can use anything, you can use. அது ஷோ பண்ண முடியாது, பட் அந்த வீடியோ let me upload this. அந்த வீடியோ go through பண்ணிட்டு you start solving a problem. Okay, so that you can able to find out the values for the velocities of required point. And one information, next week you are probably having your CA1. Okay, next Tuesday நம்ம கிளாஸ் ஹவர்லேயே வச்சுக்கலாம். வேற யாரும் அந்த ஸ்லாட்ல வைக்காத மாதிரி பார்த்துக்கோங்கப்பா. Okay, Vikram.
Sir.
You ensure nobody is having test on our hour. நம்ம ஹவர்ல யாராவது வச்சிட போறாங்க.